Hey, so this is going to be the first lab. This is actually the third take because I'm just not really sure how these labs are going to turn out. But hopefully you have your lab manual, and then you also need this paper because we're going to be talking about confidence intervals for a population mean today. And so what you're going to need on this paper is the section that I told you not to worry about till chapter 8, which is where we are now. But if you look right here in the bottom right hand corner, and it doesn't matter, or I guess that's the bottom left, it doesn't matter which side of the paper you look at, they both have this, and it says confidence intervals, critical values, z of alpha over 2, and it gives the 4 most common confidence intervals, the 90%, 95%, 98, and 99%, and then the z scores associated with those common confidence intervals. Now, when we work through this lab for chapter 8, there's actually a lot of chapter 9 stuff kind of weaved into it, so we will be skipping around. So I'll post the page numbers on Canvas so you know exactly where what we're looking at for this, but I'm trying to just supplement what you're understanding with what we're doing in the lecture and for the homework, so that way by the time it comes to writing out the homework on your own, you're feeling a little more confident in your abilities to do that. All right, so I'm going to start sharing my screen with you. Here is the lab paper, and I also want to mute myself. There we go. Okay, so we are on page 64, and I'm not going to sit here and read everything to you. My hope is that you're reading these ahead of time, and then you're coming back and you're trying it yourself, and then you come back and kind of double check that you have the right answers. But if at any time if I go through these things too fast, just pause it, take the time to read it over, and then jump back in. So here they're just talking about the different confidence intervals. Originally the proportions was first, so this is kind of reviewing the proportions, but we're actually doing the means first. So I'm just going to skip down to the means, and yeah, we totally don't need the Z chart. We need the T chart. Okay, so forget it. You don't need that yellow paper. I am not stopping and redoing this video for a 4th time, so we're just going to pretend I didn't say that. And what you need to do is make sure you have this paper. Oops, let me pop it up. This paper printed out, because you are going to use this in the homework, and you're going to use this in a lot of the notes that we're doing. And so this is called critical values, and it's based off, you can see underline the student T distribution. That's what it's called. In fact, the name of the file is the student's T distribution, because that's the name of this chart. And we will get into more about why this and all that good stuff in chapter 9. But for what we're talking about today, what I want to familiarize you with are the features of this table. So over here we have DF, and that stands for degrees of freedom. And the degrees of freedom is 1. That's a formula for the degrees of freedom. So if your sample size was 10, then 10 minus 1 is 9. So we would use the row for 9. As you go down this list, you notice, it starts off 1, 2, 3, 4, all that good stuff, until you get to 30, because 30 is kind of our magic number for sample sizes. And then once you get to 30, it starts jumping 30, 40, 50, 60, and then 80, 100, and then up to 1,000. And then the final row is Z, because there's going to be a lot of similarities between Z and our T distribution. So we're actually going to walk through this table a little more detail in a minute, but I just wanted to make sure you have this paper. And then the other thing besides the degrees of freedom, so this column was the degrees of freedom, is we have the confidence level on the bottom. And most of the time we're going to be between like 90 and 99% for our confidence level, but that will be given to us in the problem. So we're using this bottom portion, and we're using the left-hand column. We are not using anything in the gray box at the top, the area and 2 tails. we'll worry about that in chapter 9. But for right now, we're just using the left-hand column and the bottom. And so looking back here at the packet, it says the degrees of freedom is n-1. And then we are using a t, oopsies, I mean to highlight all of that. Come on, go away. We are using a t critical, okay, forget it, I won't highlight it. We're using a t critical value, not z. Look at that. Okay, anyways, we need n-1 as our degrees of freedom, and we are using a t critical value. And so here's our margin of error. Our margin of error is our t critical value. So in this book, they mark it as TC, meaning t critical. In the notes, I call it t of alpha over 2. I don't care. Whatever's more familiar. The important part is the letter T. You could just literally put T, and that's the important part. You need to know which table you're looking at, and this is for the T table. And then we're going to multiply that margin of error times the sample standard deviation divided by the square root of n. And once we get that error, we are going to come up with our confidence interval, which is the mean minus the error for the lower value and the mean plus the error for the upper value of our confidence interval. And don't worry about this. We don't write it like that. I don't like messing with that. Okay, so again, go ahead and read through this at your leisure, pause it if you want, or maybe you read it ahead of time. But what we're going to do is look at these questions regarding the margin of error. So for a given confidence level, as the degrees of freedom increases, what happens to critical value? So for all these questions, we want to be using that table. Look at that table right there. And so maybe you looked at these questions and you weren't really sure what they were asking and you didn't answer them. And so I encourage you, if you haven't answered them yet, to pause this and to go look at that T distribution table to answer these questions. All right, so we are looking at, as the degrees of freedom increase, what happens to the critical values. So looking back at this, and it said any column. So we could just start here in this column. It doesn't matter. We'll do it for a couple columns just to see if the pattern's the same. But as the degrees of freedom increase, so as we are going down this list, because the degrees of freedom is getting bigger as we go down, what's happening to our critical value? So I start off at 15.89, and then I'm at 4.849, 3, 2, 2.757, 2.6, and so forth. And as I go down this list, they just keep getting smaller and smaller. And we could check another column if you think, okay, well, that just kind of happened that way. Just pick another column, and as you go down, even these big numbers over here on the right, as you go down, then you can see that the critical values get smaller. So as the degrees of freedom increase, they get smaller. For a given confidence level, as the degrees of freedom increase, what happens to the margin of error? Well, going back, you know what, the formula is kind of far back, so I'm just going to rewrite it. But the margin of error formula is our T times S over the square root of N. And so since we said the critical values, which are the T's, I should keep these capital just so they all look the same. The critical values, T critical, is getting smaller if I am multiplying by a number that's getting smaller, then my error is also going to be getting smaller. My margin of error. So also gets smaller. And if you aren't really sure what I meant by that multiplication, let's just pick some numbers that are easy to multiply. Okay, 3 times 4 is 12. Well, what if instead of 3, I got smaller and I did 2 times 4? Well, my answer gets smaller. If I get smaller again, 1 times 4. My answer continues to get smaller. So if this number is getting smaller, just like the T of C is getting smaller, then the answer part will also get smaller. On number 3, it says larger degrees of freedom result from larger sample sizes, because remember the formula, degrees of freedom equals n minus 1. So the bigger n is, the bigger the degrees of freedom are. So what does this imply about the relationship between sample size and precision of the confidence interval? Well, as the sample size increases, so let me just kind of connect the dots here. As the degrees of freedom increase, or the margin of error, I mean, not the margin of error, the degrees of freedom, which would translate to our sample size also increasing, and the margin of error gets smaller. So if our sample size gets bigger, which is the same as our degrees of freedom getting bigger, then our margin of error is getting smaller. So as n gets bigger, the error gets smaller, and the smaller the error, the more precise the interval. So the bigger the sample size, the smaller the error. If the error is smaller, then the interval itself will be more precise or more accurate. Okay, let's see this from a different point of view. For a given degrees of freedom, as the confidence level increases, what happens to the critical values? So going back to our table, we're looking at it a different way now. So let me get rid of all of this from before. And I'm going to go down towards the bottom just because I'm looking at the percentages. Okay, so it doesn't matter which row we pick. It just says for some, let's hit a button. For some level of, for given degrees of freedom, as the confidence level increases, so confidence levels on the bottom, increasing is going to the right. So as we go to the right, what happens to the critical values? So looking here at 30, as I go to the right, the critical values are getting larger. And it doesn't matter which row you pick, going to the right, the numbers are increasing. In fact, if I even go all the way back to the top, if I go to the right, those numbers 1.061, 1.886, 4.849, 9.925. Those numbers are getting bigger as I go to the right. So that's what the question was asking. Let me go back. So for a given degrees of freedom, as the confidence level increases, what happens to the critical values? They get larger. For given degrees of freedom, number 5, as the confidence level increases, what happens to the margin of error? Well, the bigger the interval, the farther apart we get, the bigger the error. So let's just kind of draw a picture of that. We've talked about this in class that last day that I was teaching. We have X bar in the middle, and we would go plus E and minus E to get to the ends. Well, if I get even bigger, go out even more, now my confidence interval is even larger. It takes a bigger amount of space. So for number 5, as the confidence level increases, the margin of error is also increasing. In fact, I think I said that backwards when I looked at the picture. I said when the error gets bigger, the confidence level gets bigger, but you could just say that the other way around. As these confidence intervals are increasing, the margin of error is also increasing. So number 6, what does this imply about the relationship between confidence interval and precision of the confidence interval? So as the confidence interval gets wider, as the confidence interval increases, rather, let me just write this up. As the confidence interval increases, they get it. The confidence interval gets wider, thus less precise. Thus less precise. So what we're saying is the bigger the interval, the less precise the interval is going to be. And I'm going to talk about this in terms of the confidence level and the precision in the notes for this section. But here's just another picture of why this is happening. As the confidence level is increasing, the margin of error is increasing, which makes it wider, thus less precise. Okay, so there is a little modified table right here, which I totally forgot about. I guess we could have looked at that, but that is, yeah, we're just going to kind of skip right past it. And for here, I want to jump to this problem right here, this try these problem, just because there are 2 types of mean problems. There's the kind where we know the standard deviation and the kind where we don't. And so we're only focusing on standard deviation unknown. So that's what I want to look at in this lab here. Okay, so here we have, in case I went too fast, we're on page 68 now. Constructing confidence intervals. And so we have this information for 10 adult men, and we're given their pulse rates and heartbeats per minute. And so we're going to construct a 90% confidence interval. So first, we want to put this in your calculator. So put in calc, and specifically, we want to put it in L1. Put this whole thing, all 10 values, into the list 1. No frequency, so type all those into L1. And again, I'm just going to jump straight to the answer. So make sure you're pausing and you're typing it in. And you're coming up with these values, but we want to come up with, for part B, we want the sample mean, the sample standard deviation, and the sample size. So first, are the criteria for sampling distribution normality met? And so right here, we have this sentence given, assuming these values are sampled from a normal population. So the 2 choices are either the sample size is greater than 30, or it's coming from a normal distribution, a normally distributed population, just like we were talking about in chapter 7. So I'm going to say yes, and my explanation is sample size doesn't matter. In this particular problem, sample size doesn't matter because the population is normally distributed. Okay, so now we're finding these 3 values, and these are called sample statistics. Oh man, I gotta sneeze here. All right, these are called sample statistics, because on the test and on the homework statistics, it's not so obvious like this is a mean problem, like I said at the beginning of today, or at the beginning of this video. It's going to be a problem where you need to read through and figure out if it's a mean. Now it does tell you in this problem mean, so it will tell you mean or population, but I'm not going to say it in the question like part B has here. It has the actual sample statistics listed out. So on the test, I will just say determine the sample statistics, and then you would need to come up with the mean, the standard deviation, and the sample size. So the sample size is 10. You can either count it or it says there's 10 men involved. And then the mean, 85.2. And S, remember we're not using sigma, we're using S for this problem, 6.893. All right, so now we want to find the critical value associated, or that corresponds with the 90% confidence level. And remember, we need the confidence level, okay, 90, and then we need the degrees of freedom, which is n minus 1. So in this case, it's going to be 9. 10 minus 1 is 9. So I go to my table that I wrote all over, that's okay. And I said the degrees of freedom is 9. And let's get rid of some of this. The confidence is 90. Let's go. Just follow your paper up. And I get 1.833. So we'll just call it T. Oopsies, we're up here. 1.833. All right, so then we want to compute the margin of error. So we're using our T and our S and our square root of n. We get about 3.99, kind of depending on where you rounded, will be around there, around 4. And so the confidence interval is going to be our, let's see, how much space do I have? I'm going to probably write the work down here. So we're going to have our mean minus our error and our mean plus our error, 85.2 is our mean. That's my 6s. My 5s look like 6s on this machine. And we are going to subtract our almost 4 here and add. And if your numbers are slightly off of mine, that's fine, just depending on rounding or typing in your calculator or whatever. Okay, so we have 81.21 and 89.19. So that would be our confidence interval. 81.21, the smallest number goes on the left, and the bigger number goes on the right. And so to finish this up, we are going to interpret. So that confidence interval was answered E, but to interpret it, we want to write a sentence. And so the way we write all the sentences is the same. We are, in this case, 90% confident that the true mean, what are we talking on this problem? Mean resting, let's go back up. True mean resting pulse rates. And again, you just, not again, but you could just copy this. The true mean resting pulse rates for adult men oops, say adult is between, and then we give our two answers, 81.21 and 89.19. And what are our units? Beats per minute? Resting pulse rates. Oh yeah, the data values are, so I'm reading this sentence right here. The data values are pulse rates in heartbeats per minute. So all right, so for all of these interpretations, when we're interpreting our confidence interval in context, that means we're putting all of this together using the words in the problem. We are whatever percent that's given in the problem, that the true, now it's either going to be mean or proportion. That's weird. All right, I will determine later what just happened, but hopefully we were recording and then it kind of maybe just dropped off and came back. So let me go back to sharing my screen if I'm not already. All right. Okay, we're 90% confident that the true mean resting pulse rate for adult men is between, and then you just put your numbers and then your units. So everything I underlined will change in every problem, but the format will be the same. We are blank percent confident that the true mean or true proportion, and then whatever we're talking about, resting pulse rates for adult men is between, and then we give our two numbers, and finally our units. Notice the numbers 8121 and 8919, those are in number order. Okay, so this was just one problem. There's more in here if you want to do some more sample problems. There's stuff about snakes, and there's some about pigs, I think. Oh no, the pigs are in the next section. But we can look through another one of these problems. Yeah, let's just do another one since we're here. Okay, so let's go through, I'm not gonna do this next one. I wanna do the one at Abraham Lincoln High School. Here we go. Abraham Lincoln High School. So what I recommend is pause, do number 13, and then come back and check. Okay, so go ahead and go. Okay, I was trying to be boring there for a minute, so in case anyone didn't leave, they would just hear nothing. But hopefully you're back now. And so here we have a high school using a test for college placement, and it gives us a sample size, and we have already given the mean and the standard deviation, sample size, mean and standard deviation, and then we are going to assume that the test scores are normally distributed, and then finally it gives us our confidence interval. So are the criteria for approximately normality satisfied? Yes, just like last time, population is normally distributed. So we don't need to worry about the sample size because the population is normally distributed. Okay, determine the sample mean, standard deviation, and sample size. Well, this is a lot quicker than last time because they give it to us in a problem. They didn't give us a table and to calculate ourselves. So we're given those numbers right there. Determine the critical value that corresponds to the 99% level of confidence. And so since our sample size was 15, our degrees of freedom was 14, and again, 99%. So that will be over here. Where is it? 14. So we get 2.977 as our T. So for the margin of error, calculating it using our T times S over the square root of N, and then I rounded it and got 18.5. And we want to give the confidence interval. So we have, don't have as much room here. So I'm going to write it off to the side, X bar minus E, X bar plus E. So we're taking our mean, we are subtracting, and then we are taking our mean, and we are adding that margin of error. So our lower bound would be 506.5. Our upper bound would be 543.5. And so our confidence interval would be 506.5 to 543.5. Finally, to interpret it, we are 99% confident that the true mean achievement test score is between 506.5 and 543.5. I forgot to write the units in my notes, so let's just double check. It doesn't give us units, but they're test scores, so I'm guessing points would be a good word to use for units. All right, so that is it for the lab that we are doing here, and now hopefully you're ready to watch the lecture. I don't know what I'm looking at. I don't know where I'm off to the side over here. Oh, I could probably just look at the regular camera. Okay, so I hope that helps you kind of have a base understanding, so that way now you can watch the notes and be ready to jump in on those problems. All right, see you later. Maybe actually, okay, now I'm gonna really go.